Free body diagrams, yes. So we got to know what are they and why do we need them.
Okay.
So what are they? They are a diagram that show all of the different forces that are acting on an object at any one moment.
Okay. So should we draw this?
Yeah.
Okay.
And we got to talk about why we need them too. We need them so we can see how an object is going to be moving. Okay?
Okay.
So let's talk about, we'll say hypothetically a car. Okay?
Do I have to draw the car?
You don't ever have to draw a car. You could just draw it as a box.
Okay, I'll do a box.
That's what I like to do whenever I'm drawing my free body diagrams. We'll start with a box. All right? So we'll say gravity's pulling it down.
So that'd
we're
be
going to draw an arrow going down. Okay? We're going to label that arrow with the force gravity is affecting it. We also have what's called the normal force, which is going to be perpendicular to the angle of it that it's resting at. So that will be going up. Normal means 90 degrees. So it's perpendicular from the bottom of the box. Perpendicular from the ground. All right?
Okay.
And then we have the force applied to an object. So if I'm pushing the car, if I'm giving it some gas, that's the force pulling it, causing it to go. In this case, we're going to the left side. So we're going east. And then there's also the frictional force, which is going to be pushing it in the opposite direction. It's what's resisting it from going forward. It's like if you let off of your gas, your car slowly comes to a stop. It's because friction's pulling it back. So these are the four forces we're really going to be talking about in a free body diagram. So on a net force is if it's balanced or not. So if gravity is pulling something down, we'll say at a force of 500 newtons, and then we've got a net force pushing it up at 500 newtons, we know it's not moving left or right because those two are balancing out. This one's the same as that one. But if we are accelerating, we'll say with a force of 300 newtons. But friction is only 100 newtons. We know that these two forces are not even. So that means it is accelerating to the left side, to the direction of the applied force.
Okay, so we have our 300 and our 100, right?
So how many newtons is it accelerating?
So I would subtract that, correct?
Yes.
And that would give me 200 newtons.
So it's moving with a force of 200 newtons in the direction of the acceleration.
And that would be my force applied, correct?
Right. Just to run through all four of these forces real quick. We have the force of gravity, the force of friction, the normal force, and the force of acceleration. Gravity is what's pulling it down, friction's and normal force is pushing it back up. Acceleration is the direction we're going, and friction is pulling it back. Okay, so if the net force is 0, like between our normal force here and our gravity force here, then that means it is either not moving, in this case, like if something's resting, it's not moving up and down, or it's moving at a constant speed with no acceleration. Like think about the Earth orbiting around the Sun. It's moving at a constant speed. It doesn't have any force pulling it anymore because it's at a constant speed. It's not accelerating. Is that it?
So we're gonna go ahead and do some guided practice.
Yes, let's,
So that is on page 4 in your packet, under guided practice.
yeah, written underneath the note dot outline.
Yes. Okay, so the question asks, a tow truck is pulling a car with a force of 5,800 newtons.
Okay, hold on a second. So we've got a car. So I'm not going to draw a car. I'm just going to draw a box because that's easier. Okay, so it said a tow truck is pulling a car with a force of 5,800 newtons. So we're going to say it's pulling it this way.
Okay?
And it's pulling with a force of 5,700? 800.
Great.
Okay?
All right, the car has a weight of 14,700 newtons.
Okay, so if it's a weight, it's pulling it down. And what's the number again?
14,700.
Okay?
The road exerts a force on the car of 14,700 newtons.
Okay, so if that's the force the load is pushing on the car back up, so that's going to be our normal force. So that's 90 degrees from the bottom of my box here. So that's going straight up like that. And that's 14,700 newtons.
All right, the next one says the force of friction on the car is 775 newtons.
Okay, so friction is going to be pulling the opposite direction as the way we're accelerating. So it's going to be pushing it this way. And
775. Okay, it's telling us to find the net force.
okay, so let's take a look at our arrows. We've got one here and one here that are going in the opposite directions, but they're the same number. They're both 14,700. So those two forces are going to completely cancel out because they're equal and opposite. And then we've got this force right here pulling it to the right, and this force right here pulling it to the left. So we're going to have to subtract those two numbers. So we've got 5,800 minus 775, and we get newtons. So that's a net force in the forward direction of 5,025 newtons.
And that would be our applied force, correct?
Yes.
Okay.
All right.